In this video, we're going to look at three different ways that we can go about solving a system of equations. And the first system we have here is 2x minus y equals negative 3 and 4x plus 3y equals negative 21. So we're trying to find the value of x and y that will satisfy both of these equations at the same time. So the first technique we want to look at with solving this system is using substitution. And to use substitution, you want to pick one of the equations. It doesn't matter which one we pick, and you want to solve for one of the variables. And if we look at each equation, which variable is going to be easiest to solve for? Well, I think if we look at the first equation here, because we simply have a y here by itself, in other words, here we have a 2x, a 4x, and a 3y, and this is just a negative 1y, it's going to be a lot easier to solve this equation for y. So we're going to take the first equation, 2x minus y equals negative 3, and we're going to solve for y. So to get y by itself, we're going to subtract 2x. So we would have a negative 2x, subtract to the other side, minus 3. And then to get rid of the negative, we're going to multiply everything by a negative. So the negative and the negative here makes it positive. The negative 2x then becomes positive, and the negative 3 becomes positive. So now that we've solved this equation for y, we can then take the 2x plus 3, because this is equal to y, and substitute that into the other equation. So we're going to substitute that in place of this y. So therefore, we would end up with 4x plus 3 times y, but we know y is equal to 2x plus 3. So we're going to plug in 2x plus 3 equals the negative 21. So now we simply have one variable. So the idea of using substitution is we eliminate one of the variables. So now we can solve the equation for x. So we would have 4x plus, distribute the 3. So then we would have 6x. And 3 times 3 is 9 equals a negative 21. And 4x and 6x, that will become 10x. And we want to move the 9 to the other side, so we're going to subtract 9 from both sides of the equation. So we would have 10x equals negative 21 minus 9 would be a negative 30. And then, of course, to get rid of the 10, we're going to divide by 10. So dividing by 10, we would end up with a negative 3. So we now know that x is equal to a negative 3. So now we need to find the value of y. Now, in order to find y, we simply can substitute this value in for x. Now, we can substitute this value into either equation up here at the top. We can plug negative 3 in for x. Now, I would suggest to make it easier, if you notice over here, we've already solved the first equation for y. So to make this easier, we're going to take the negative 3 and plug it in for x here. So you get y equals 2 times x, which is a negative 3. And the advantage here is we already have this solved for y, so all we have to do then is take 2 times negative 3, which is a negative 6, and then negative 6 plus 3, and we'll find out the answer for y is also a negative 3. So the answer is x needs to be a negative 3, and y also needs to be a negative 3. All right, the other way that we can go about solving the system of equation is by graphing. And if you notice here, we're going to use the exact same system, 2x minus y equals negative 3, 4x plus 3y equals negative 21. But this time we want to graph each equation. So I'm going to take the first equation, which is the 2x minus y equals negative 3. Now, if we want to use the calculator, we can do this by hand. If we use the calculator, we need to solve the equation for y. So if we do that, we would have negative y equals negative 2x minus 3. And just like we did before, multiply by a negative, so that makes it a positive 2x and a positive 3. And then if we take the other equation, the 4x plus 3y equals a negative 21, and here again, we're going to solve for y. So we would have 3y is equal to negative 4x. Again, we want to subtract 4x to move it to the other side. And then to get rid of the 3, we're going to divide by 3. So y equals a negative 4/3 x minus 21 divided by 3 would be 7. So if we want to do this by hand, we could certainly do that. In other words, we could graph this equation. We know that for over here in the blue, we have a y-intercept of 3 and then a slope of 2, so we could use that to find the graph. And then over here we have a y-intercept of -7 and a slope of -4/3. But let's go ahead and use the calculator and see what we can come up with. So we're going to type in, go to y equals, and we'll type in the 2x plus 3 for the first equation. And the second equation would be a -4/3 x minus 7. And I'm going to go to zoom 6 to standard view. And that looks pretty good. If you notice here, what are we looking for? Well, we're looking for where the lines cross right here, because that's the point, what they share in common. That's the x and y value that's going to make both of the equations true. So let's see if we can zoom in a little bit. And I don't want to zoom in on the origin, so I'm going to actually move the cursor to the left and down to this point here where they intersect. Okay, so we've zoomed in here, and what we're looking at is where do they intersect here? And if we look carefully, this would be over -3 and then down -3. Okay, and if you wanted to verify that, we could also go to second trace, and number 5 is intersect. And it says your first curve, and simply that means the first line. So the cursor's flashing here. This is one of the lines, so we're going to hit enter. And notice it says second curve, and the cursor moved to the other line, so you're just going to hit enter. And we want to guess where they intersect, so I'll just move the cursor to this point where they are intersecting. And we hit enter. Notice it tells us the answer is -3 and -3. So what we have found is the solution for this particular system. Now keep in mind, with this, we're trying to find the x and y value that will satisfy both of the equations at the same time. So that means they must have a common point, and that's going to be here at x is -3 and at y is -3. So if we were to plug -3 in for x and -3 in for y, both of these equations would be true. All right, the third technique we're going to look at is using elimination. Okay, so here we want to actually add the equations together to cancel out one of the variables. And there's a couple ways we can do this. If we were to add the equations the way they are, we would get a 2x and a 4x, which would be 6x, and a -y and 3y would be 2y. Well, we want to figure out how can we get those to cancel out. Well, if we take the first equation, and if I was to multiply by a 3, we would get 6x minus 3y equals a -9. Now, what's the advantage of doing that? Well, if we bring down the other equation, leave it alone, we have 4x plus 3y equals a -21. Now, why did I pick 3? Because when I take this 3 and I multiply here by the -y, I'm going to get a -3y and a +3y. They're going to cancel out. So here, we're going to get 6x plus 4x. We're going to add the two equations together. That's going to give us 10x. -3y, +3y, they're going to cancel out. -9 and -21, that's going to be a -30. So 10x equals a -30. So if we divide by 10, x equals, once again, a -3. And then, of course, at this point, we would simply take this value and plug it into one of the equations. And I would say let's take and plug it in up here for x, and we would get 2 times -3 minus y equals -3. So that means a -6 minus y equals -3. So a negative y equals, if we add 6 to get y by itself, we're going to add the 6 so they cancel out here. So we're left with a negative y equals 6 minus 3 is 3. And in order to make this a positive y, we need to multiply both sides by a negative 1. So that gives us a positive y, and then we have a negative 3. So here there's 3 ways we could solve this same system of equations. We can use elimination by multiplying so that we can add and cancel out one of our variables, and once we cancel out a variable, we can solve for the other variable. Or we can certainly use graphing. We can find out where do the two equations intersect. That's going to give us the solution. Or we can use substitution. We can solve one of the equations for one variable and then substitute that expression into the other equation.